This problem it wants us to, this is 49 from 8.4, perform the operation, show the answer in both trigonometric form and standard form. Negative I over 1 plus, that should be an I. And so we have two vectors to look at. And I'm just going to caution you, though, I mean, the way I've done this problem pretty much every time I do it and I go look at the answer, and it's the same answer, but from a different perspective. I'll just caution you that. So Z1 is going to be this negative I. So in that, I'm going to say that A is 0 and B is negative 1. So the magnitude of Z1 is going to be the square root of 0 squared plus negative 1 squared. That's the square root of 1, which is 1. And if you think about where this is located, so negative I is just down here. And so I always look at it from this direction where I say that's 3 pi over 2. But the book, for some reason, keeps looking at it, well, keeps every time I look at it, looks at it as negative pi over 2. And really either direction's okay. Just understand, and I know that some people have a hard time thinking that one point has multiple or an infinite number of ways to get there. So I've been doing, like I said, 3 pi over 2, but it's equivalent if you do negative pi over 2. So I'm going to say my Z1 is going to be 1 from the square root of 1 times cosine of 3 pi over 2 plus I sine of 3 pi over 2. And then our Z2 is going to be that 1 plus I, so that my A is 1 and my B is 1. So the magnitude of Z is going to be the square root of 1 plus 1, 1 squared plus 1 squared. Square root of 1 plus 1, which is the square root of 2. And if we think about where that's located, 1 and 1, that just makes this here. I think you can probably guess what the angle is. But tangent of theta is b over a, so 1 over 1. So theta is tangent inverse of 1, which is pi over 4. That one I wouldn't go for the negative 5 pi over 4. Okay, so my Z2 can be expressed as the square root of 2 times quantity cosine of pi over 4 plus I sine of pi over 4. I think I got enough parentheses there. Okay, so our Z1 over Z2 is going to be 1 times cosine of 3 pi over 2 plus I sine of 3 pi over 2. And then the Z2 is the square root of 2 times cosine of pi over 4 plus I sine of pi over 4. And this is the cool thing about this type of division. You're looking at that 1 over the square root of 2 and then times cosine of this angle in the numerator, 3 pi over 2, minus the angle in the denominator, pi over 4, plus I sine of 3 pi over 2 minus pi over 4. And this gives us 1 over the square root of 2 times cosine of 5 pi over 4 plus I sine of 5 pi over 4. There. Now I just want to show you where that is. I mean, hopefully you already know where that is. That this is 5 pi over 4. The answer in the book is negative 3 pi over 4. It gets you to the same place. And so what they did instead, they said that Z1 was 1 times cosine of negative pi over 2 plus I sine of negative pi over 2. And then you have Z2 is going to end up being that square root of 2 times cosine of pi over 4 plus I sine of pi over 4. And in that case, it's still 1 over the square root of 2, and then cosine of negative pi over 2 minus pi over 4 plus I sine of negative pi over 2 minus pi over 4. And in that case, they get the 1 over the square root of 2 times cosine of negative 3 pi over 4 plus I sine of negative 3 pi over 4. But I still want to stress that the 5 pi over 4 and negative 3 pi over 4 get you to the same place. Okay, hope that helps. Here's my addendum to this. I forgot the last part. We're supposed to also give this in a regular standard form. So that'd be standard form here. 1 over the square root of 2 times what? So cosine of negative 3 pi over 4 is going to be negative 1 over the square root of 2, or negative square root of 2 over 2. And sine of the negative 3 pi over 4, or 5 pi over positive 5 pi over 4, is also going to be negative 1 over the square root of 2, or negative square root of 2 over 2. So if we multiply that through, we end up with a negative 1/2 plus I times negative 1/2, or it's negative 1/2 minus I over 2, which I believe is the answer the book shows. Okay, hope that helps.